Welcome to Inside the Hive.tv podcast. I'm your host, Dr. Umberto Boncristiani. In this podcast, we talk about the teachings of the most successful society in natural history, the honeybees. It doesn't matter if you're a beginner, an advanced beekeeper, or just curious about honeybees. Here, you'll find great conversations to educate and entertain yourself about this wonderful insect. From honeybee biology to how to make money with honeybees, you won't miss anything here. Inside the Hive.tv podcast is brought to you by our fans on Patreon. On Patreon, you can access all episodes before anybody else and exclusive content, like behind-the-scenes videos, live streams, and more. If you want to learn more about honeybees and help me to make more content about honeybees to everybody, please visit patreon.com/InsideTheHiveTV and join our community. I'm becoming increasingly interested in honeybee resistant to Varroa mite in nature, and in this episode I had the pleasure of speaking with Dr. Melissa Oddie, a honeybee researcher at the Norwegian Beekeeping Association and author of several scientific publications on this important subject. I hope you enjoy this conversation. All right, Melissa, we are finally having this conversation. It's been a while. I'm trying to get in touch with you. I read a lot about your work. I am personally getting more curious about the subject of your work and to learn more about the bees in nature, how we can learn from them and maybe apply some of those lessons to improve the bees around the world somehow. So can we start with your background of how you got into bees, where you're working right now, a little overview about yourself for the people at home that doesn't know you.
Yeah, I can do that. So I can probably start like right at the beginning, because I pretty much knew that I wanted to work with animals, specifically conservation, since I was about 6 years old. And I can pinpoint the exact time if you're into a story. So I used to watch Bill Nye the Science Guy as a kid, which should date me pretty well. And there was an episode on biodiversity. And there was this one segment that he did where he was talking about the ecosystem balance and needing all of these species. And as he was talking, he was pulling bricks out of a tower that he had made, each with a species on it. And when he got to his point that, the ecosystems needed these diverse, needed the biodiversity to persist, he pulled one brick out and the whole thing came down. And that was like a hammer to the back of my head. I was like, this is what I'm going to do. This is what I have to do. So from that point, I pursued sciences as much as I could. I'd always been fascinated with honeybees. I was the kid in the playground who used to pet bumblebees on the backs. And all the other kids thought I was crazy. But that stayed with me. And I did an undergraduate degree at the University of Toronto, zoology specialist with major in conservation biology. Did that, got through that, and then realized that I probably wasn't going to be very hireable without any experience whatsoever. And going abroad seemed the best way to broaden my vision and experience. So I started a master's at Exeter University at the Falmouth campus, and I did wild insects in agricultural landscapes. But the country that I actually did the work in was South Africa. So I went for 3 months in South Africa looking at wild pollinators. And from there, I started to learn a bit more about honeybees, how fascinating they were. And I caught wind of, how much trouble they were in, because I picked up on the media hype, save the bees. And I learned about Varroa. And then I caught a few papers by Barbara Locke and Yves Leconte on some populations that had started to adapt to Varroa. And I was like, ooh, that is so cool. I think I want to do that. There was a researcher working on bees at Exeter, but where I got a position actually is I sent a written letter with a CV to Professor Peter Neumann at the Liebefeld Institute at the University of Bern, saying, I want to work on Varroa resistance. I think this is my thing. So if you have any work for me. And it just so happened at the exact same time that my supervisor currently, Björn Dahle, reached out to Peter Neumann saying, hey, we've got this population in Norway of Varroa surviving bees, quote unquote, because we don't know anything about them. Do you have a researcher who wants to come up and do this? So I got hired on as kind of an intern while we waited for funding, and lucky enough, the funding went through. So I started my PhD, and that's what I've been doing since. So I've been working on the Norwegian population. I got a chance to work on the Swedish population, the French population as well, the Avignon population of resistant bees. And I can give you more information on these populations if we need to catch the readers up to speed on what I'm talking about. So I've been working on Varroa resistance since then, since about 2015. And I have learned so much about honeybees, about Varroa, about how they adapt, how they overcome challenges in their environment. And so I think that pretty much covers everything.
Yeah, we're gonna talk about these special communities of bees that you're working on, and I'm very curious to know details about them. So I don't know if you know, as a consultant for the beekeeping industry, I have a tendency to get the knowledge and some people pay me for advice, which is very hard to do in beekeeping.
I'll bet.
Which is very hard to do in beekeeping with beekeepers with different sizes, different business models, different bees. The amount of variables that we have in this, industry I think is the highest that I know. There is no other industry that I see that kind of variables, and it's so hard for me to be confident to give advice for people that are paying me. So I study a lot. I've been doing this for almost 20 years now, and I still unsure what to tell people regarding honeybees. So for you to have an idea how things are being hard on my side, I get it. And so I start to look at those. I start to go back to my roots. I'm from Brazil, and in Brazil, nobody treats. Very, very few people treat for Varroa mite or for anything in general, actually. First of all, not because they don't want, most of them don't have the resources or the knowledge. So
it is most of the world.
Yeah, most of the world. You're correct. And when I go back home and I start with people and talk with people at home, everybody seems fine. Everybody seems to have adapt. There is stories in the past that, things got bad with the introduction of Varroa. Things, people lost profits and situations changed for a while. To me, looks now things have normalized for those communities. I can't speak for the whole Brazil beekeeping industry because Brazil is a continental country. It's bigger than the United States if you take Alaska out of the equation. So it's hard to say everything is okay there, but I have a feeling from the few people that I'm talking to, people are fine. So I start to get curious about what would happen here in the United States, for example, if you start to go that direction. Can we go that direction? There is any kind of bees populations maybe here or close by that we could learn from or use the genetic from to start a new trend. And at the same time, there is a trend here in the United States of people that are looking for this kind of information. I know a lot of beekeepers that wants to breed for specific things, and which is complicated in my perspective. So I want to get your brain in this whole conversation. So, but before we go there, I want you to tell me, why study honeybees population surviving Varroa mite naturally? So you engage at that. From my perspective, I want to learn what are those traits and maybe bring them to the systems that we have in place. But today, I don't know if I believe this is possible. So I want your take on that.
Okay.
It's a little too much, but we can dissect. We have time.
So, I mean, if you want the short answer, you are very right, and that this is an extremely difficult thing to do is give people advice, because a lot of times people want kind of solid blanket advice for every single scenario, or they want a silver bullet. And unfortunately with honeybees, it doesn't look like that is ever going to happen. You have to analyze each individual scenario and in each environment, each condition, how many apiaries, how many hives, and what type of bees you have and the situation. And you probably have to cater solutions to each different scenario, to each different setting. It's hindered understanding a lot because you have one specific setting and a study is done with one specific set of parameters, and they'll find a result. And then you have the study repeated, but with a different set of parameters, different bees, different country, different density, and they will get a different result. Both of those people swear that their result is the real result, and this is what you have to do. But neither of them are wrong. They're both right. It's just they are right under specific conditions. the way I approach science, the way I approach what I do and how I find answers and how I interact with other people who also have answers goes back to a really cool story. I'm not exactly sure which culture in India, but it's an Indian folktale. Do you mind if I tell it? Because I think this is going to be fundamental for my perspective and how I communicate, what I'm talking about. So it's called The Seven Blind Men. And I think in North America, we'd probably know it as The Seven Blind Mice, because it was covered on a show, again, way back in my past, called Reading Rainbow. And it goes like this. So there are 7 blind mice, and they live around a water hole where life is easy. And one day, something new shows up to their place. And the first mouse goes out to explore, figure out what it is, and comes back and says, "Oh, it's a giant pillar." And the mice were like, "Okay, this is weird." So the next day, another mouse goes out to investigate and comes back and says, "It's a snake. We need to get out of here." But it was completely different from what the first mouse had found. So third day, the third mouse goes out. It's like, "Oh, it's just a piece of rope. So this is nothing." The first 6 mice go out, and they each come back with a different answer, and until it's the last mouse's turn. And he goes out and he runs up and down and around, and just kind of looks at every single part of what this thing is. Another mouse had said it was a spear. There was a fan involved, a mountain, and he takes all of these things together, puts them in one specific picture, and he's like, "I know what it is. If you take all of these things, because all of those parts belong to the same thing, and if you pull back, you find that it's actually an elephant." And it's cool because there's this picture of an elephant. So this is basically what science is. Every single researcher, every single person who's looking at this problem has a different piece of the story. And if you take that into account, that people have done their work well, and everyone has one piece, but it doesn't quite fit sometimes with what other people have, the other pieces of the elephant that people have. But, if you try and think of a way in which these pieces could fit together, I think you get closer to the truth. So that's how I approach it.
I love it. That's exactly. It's a puzzle, and we don't have all the pieces. And the pieces sometimes look different, depending on the angle. They might be more similar than you think. And that's the beauty.
But we're all on the same side. So we're all trying to figure it out together. And if you keep that in the back of your mind, it tends to work out pretty well. So I'm going to draw back and ask you what the original question was, because I think I got a little sidetracked there.
So the original question was, why study them? Why get involved and why study honeybee population surviving Varroa naturally? And then I jump in talking about my problems with science, not with science, but how to communicate and make my potential customers or clients and people that I want to advise to understand the difficulties of those puzzles. With everything that's going on in the world today, some anti-science people coming in and taking advantage of this it's not an inconsistency. It's part of the game, but people don't understand what the game is about those puzzles.
They use these different pieces to delegitimize the story.
Yeah, that's the word I'm looking for. Thank you. So I'm dealing with a lot of that, and something that I saw is that the people that are most aggressively against these things are the people that need the help the most. And so I don't know how to go through that, how to find a way to navigate into their minds and help them out, because they truly need more help than than other people. But the
sometimes
reason
it's not. I would say sometimes it's not an issue of good science. Sometimes it's a social issue.
Yeah,
and communication is just as important as solid science.
Yes, but that's then the question comes: why study those surviving Varroa mite naturally? How those pieces of the puzzle could help the people in the beekeeping community, for example? Why we want to learn from this naturally surviving bee? That was the original question, because I want to use that. I want to use those teachings, those lessons to perhaps help people. How can we help people with those information?
So this touches on a bigger issue in that historically we've always been able to affect our environment and change it to our liking. Now we're running into problems that we can't just instantly change. I mean, they've always been around, but in case of Varroa, my train of thought just crashed. Hold on.
Varroa is complicated.
Why learn about Varroa? So the answers sometimes are not kind of what we can do, how we can affect things. But what can we learn from how nature has persisted and how it solves problems? So one of the degree titles I have is Evolutionary Biology. And evolution is basically the natural system in place that takes seemingly random genetic changes and allows things that have specific advantages based on those changes to persist better than those that do not have those changes. It's an absolutely flawless system in its flaws, in that because these changes happen by accident, you have a system that is self-repairing. So you have something that tips out of balance, and then something changes and it goes back. And sometimes species go extinct, but it's actually quite rare in the general scheme of things. Mostly things adapt. So when you're asking, why study natural resistance, it's an interesting concept, and for different countries with different situations, it is more or less important. So I come from a European research background. I was raised in Canada, but I've been working on honeybees in Europe exclusively. The populations are a lot smaller. The way they do beekeeping is different. Norway has one of the lowest hive densities in Europe. So natural resistances is a very viable strategy for a lot of beekeepers here. They're fairly small scale when you compare them to North America. So in Europe, it seems pretty obvious to a lot of beekeepers, and that's shown in that there's a lot of interest in beekeepers, both commercial and hobby, to pursue natural resistances and see if you can build on them and harness them. And I think for kind of the future of agricultural systems, looking at natural systems and how evolution solves these problems and taking that into account rather than keep on trying to change a system when we don't fully understand exactly what's going on, I think it probably will turn out for our benefit in every case.
More information is always better. I like to say that information is never too much. Can't take advantage. Maybe we're asking the wrong questions sometimes, and then times correct us. So the way I see you touch base in something very important here. Yeah, the beekeeping in Europe is very different from the beekeeping here in North America. So perhaps I am biased to find information that I can immediately use to help beekeepers that are in a breach of, collapse, and lose their operations, and there is a lot of consequences on that. People are going to lose their livelihood. People are desperate. Yeah. Some people are desperate. And
there's as I understand, there's not a lot of assistance that the government offers in those cases.
Well, yeah, that's I would say it's American way. I would say the government is not helping too much because it's part of the culture too to have perhaps a small government, and people taking care of things in different ways. I'm not criticizing America at all. Actually, if you people at home know, I'm a big fan of America. Since that's why I moved here. My nickname in Brazil was American Boy, so I think that says a lot. But not criticizing, but we need to face some truths here. The system might be reaching the edge. There are people collapsing. I have calls. I have people that come to me all the time and asking for help, and I can clearly see this. Some people have no return. The bees are in a situation that will die. There is nothing we can do about it, and it's very sad. I think perhaps the question is what can we do to make it better so we don't have those constantly failures, gigantic failures, because when you reach that kind of size, I'm talking about beekeepers. I don't know in Europe, but the average here is people that I work with is 3,000 hives or more, 5, 10, sometimes 60,000 per beekeeper. So it is a different beekeeping, and the amount of work that I need to do to start be able to give some advice is humongous. I need to study the environment. I need to study the bees. I need to talk with the crew. I need to talk with the beekeeper, the master beekeeper. I need to understand the different philosophies. I need to test the water here. I need to see if people understand honeybee health and biology in certain levels. When I grab all those information, then I start to, okay, let's put this plan and test it. Because my module here in this channel is always the same. We need to test for your need. Everything we're doing here is for your needs because all the variables that we just talked about. So my bias is all of that. How can I use new information to bring to my system and help my people? And I'm having a lot of trouble to help more people and expand my help. But when I look those publications, for example, publications like yours, I start to see a pathway which might be better for the system here, but I'm gonna need it's gonna be a learning curve because a lot of things gonna need to change. And the beekeeper gonna need to understand at the end of this game, he's probably not gonna get as much money when the things are running well, but it's gonna be more consistent. And he's not going to be in those high risk of completely failure and lose everything. So that's my convincing part now to the beekeepers here in North America that changes might not be a bad idea if he wants, to have more security, I would say. So that's why I'm looking to these projects, what can we learn from the bees in nature? How can we use this information? So that's why I start talking with people like you that is dedicating your life to that. Basically, your PhD is in these populations. What can you tell me about those populations? What can you see when you go to these populations that never saw treatments against Varroa? And I know you compare with other populations. What kind of genetic traits or behavior you're able to see in those populations that make them, be more less sensitive to Varroa infestation?
Well, that's a really good segue into the papers that we want to talk about, because the Norwegian population that I had the privilege of studying is quite unique, or was quite unique in the body of scientific literature that I was familiar with, because it was the first stock that was published on in the scientific community that was commercially viable, so that the beekeeper actually used it for honey production. They were big colonies, really gentle by European standards. They produced competitive levels of honey for the regions, and they were extraordinarily gentle. So I got to work these bees myself. They are very nice. They sit still on the comb. There's no fuss. They're not flighty. They're good to be moved because they do the heather trek in Norway. So they have raspberry, which is the primary flow for honey production, and then in August they ship them up to heather and get that flow as well. So they displayed some really interesting traits. So I recorded the bottom boards first when I started this research, and they were consistently low. And I did a study which isn't technically published yet, but when looking at the levels of Varroa, I basically counted mites every single week. So there was no day the colonies were without a bottom board. And I had these control colonies from a population that was regularly treated. And these Norwegian bees basically stayed at around 5 to 10 mites a day for pretty much the whole season. Like the line was just almost flat, and then it was back to 5 a day, which seems pretty high for non-resistant colonies. But these guys, they could do it, and they seemed pretty fine with those levels. Whereas the control colonies just kind of had that really signature exponential growth curve in Varroa. And I actually had to stop the experiment early and treat them because I was afraid it was going to happen to them if I let it go like that. So that's the evidence I have. And they've done this consistently. They have consistently lower Varroa reproductive rates when the behavior is switched on, so when they're actually applying pressure to the Varroa. And those traits, the SMR, suppressed mite reproduction, so the lower reproductive rates in Varroa, that was consistent in Sweden, in France, and in this Norwegian population. So they all had this SMR trait. And we had to figure out exactly what was going on. There is a lot of literature on what exactly the bees were doing. And I think it boils down to, it's very likely a combination of things that give you this trait. And the questions I'm asking now with my research is, okay, well, how do we harness this for beekeepers? What's better to run a selection program based on performance, or based on trait tracking, or based on lineage? And that is the type of work that I'm doing right now. But this paper, we were talking about the rapid parallel evolution overcomes global honeybee parasite, I believe is the title of it.
Yeah.
And that was...
People at home, we will leave a link in the comments of the podcast or in the description of the video so you can have access to the paper. And if you have questions, don't hesitate to leave a comment or ask me in my email, as you guys normally do.
Yeah. So this paper basically looked at 4 different populations. There were 2 in France, 1 in Sweden, and 1 in Norway. And this is the second paper that I published on the Norwegian bees. The first one kind of giving a report of the SMR traits and the levels of Varroa from the bottom boards. But it also looked at Varroa sensitive hygiene, so the amount of brood removal on comb, and the amount of grooming, which was done via a proxy for mite damage. And we can talk about the methodology and what works and what doesn't about it, because there were things that I would change now that I did not know when I was doing the study. But the general profile of the bees when I ran this experiment was they had lower Varroa, they had SMR, but I didn't find any brood removal, which is weird because that was the piece of the elephant that nobody else had. Everyone else found brood removal in resistant hives, and I haven't found it yet in Norway. Not to say that they don't do it, they just didn't do it when I ran this experiment. And not too much mite damage either. But anyway, using mite damage as a proxy for grooming is problematic, and we can go into that a bit later. So that was the first paper. And the interesting thing about the Norwegian bees, because I'll share a secret with you. It's another story. I was actually set to find Varroa sensitive hygiene. So I designed the experiment specifically to find that. And I was running the experiment and I was not finding Varroa sensitive hygiene at all. I was dissecting these frames, looking at the brood maps that I had made and the photographs, and it was not working out. But the interesting thing is I had actually read some papers that were published earlier by the Baton Rouge lab, Harris and Harbo, I believe. And they were talking about Varroa sensitive hygiene, brood removal, and then they talked about this trait called recapping. So, and they explained it basically as a byproduct, an incomplete form of brood removal, and that bees would open the cell caps, not remove the brood for whatever reason, and then another bee would come in and cap it back over with wax. The interesting thing is I did not find high levels of brood removal, but I did find this recapping. And I found it at extremely high levels, and you can see the graph in the paper. It basically, the surviving bees were recapping cells at a much higher rate than the controls I was using, and the highest rates were in cells that we found were to be infested. So this behavior was targeted towards Varroa-infested cells, which is absolutely fascinating. So the 2018 paper started when I went to my colleagues in France and Sweden. I was like, hey, can you check for this behavior? Because I found it in these Norwegian bees, and it's really weird. So we did. We ran the SMR studies again, and we looked at recapping as well. And we found that, recapping was much higher in all of the surviving colonies. And again, much higher in cells that were infested with Varroa. So this behavior was targeting Varroa. And it was very, very present in populations that we knew had these surviving traits. And since that paper, other labs have gone on to look for it in different populations. And they've pretty much found it in everywhere they've looked for it. They found it in Cuba. That was Stephen Martin. He published on the honeybees in Cuba are fascinating because they are European stock bees, and the entire country is completely surviving. They couldn't afford treatments, so they didn't treat. And it was terrible for a while. And then they got back on top of it, and now they have resistant bees. So there's recapping there. There's recapping in populations in Brazil. So they found it in a lot of different populations. So the question then I asked, okay, so we know it's present and it's highly associated with colonies that can survive Varroa. Can we harness this? Can we use this as a trait? And that's the stuff that I'm hopefully going to be publishing on in the not too distant future. What I have is a breeding program that I'm starting in Norway with a different population of honeybees, a Carnica population, so distinct from the buckfast that I normally work with. And the question is, can we do this performance-based breeding program where we just measure, Varroa counts on the bottom boards and then track the traits to see if they correlate and then figure out exactly the best method. So all that to say, and now this is in a Norwegian environment. We have very low hive densities, so it's quite easy to do it here. I would say you could probably do it with any population of bees, and you can get surviving bees. But I think the low density and the cold temperatures give us a very large advantage. I'm not sure how it will work if you have, 500 plus hives in a bee yard where all the bees are flying around and interacting, and there's horizontal transfer of mites everywhere. I think that's probably one of the largest factors of mite spread, is bees sharing mites between colonies rather than the population growth in the hive solely. So that is kind of like an overview of the paper and a little bit of information surrounding. I'll probably let you lead on with the next question. How we work on what's next.
I read the paper. I am working on a video about the paper, specifically video to educate the people at home about the details of the work. But I want to pick up your brain regarding, you saw in that population, they are very stable with mite counts. This is one. Number two, you saw that recapping happens, and there is this correlation. The people that the bees that have more the recapping behavior that you saw are the ones that are surviving more in those populations. Let's hypothesize, okay, recapping is involved with that. What do you think is mechanistically would be the process? I know this is very hard. Do you think it's when they open, those bees are more capable to tell the bees outside the cell, look, there is something going on. Something's wrong with me. Can you help me out? So the bees outside go open that. Then maybe they do something, or only the process of opening, dehydrate or change the ratios of gases, and then may be problematic for Varroa reproduction that way. Do you have any hypothesis how recapping might be mechanistically making difficult for Varroa mite reproduction?
So I have some ideas. I'm still not convinced that recapping is kind of the be-all and end-all trait. I think it could still very much be a proxy to brood removal. But the interesting point there being recapping is once you've trained your eye to see it, it's actually quite easy to see on a frame, and you can just pick up a frame and look at it. Testing for brood removal is extremely time-consuming. We're going to go back. Sorry, what was the question? I've got 100 thoughts a minute in my head here, so
don't worry. I will edit all those moments. Don't worry. So the question, I'm trying to see if you have some hypothesis about how recapping would influence the Varroa reproduction.
That was it.
Yeah.
Right. So then I was talking about it could still be a proxy for brood removal, and brood removal could still be one of the central traits that we need to look for. I'm not entirely convinced, but then how would recapping actually affect the reproductive success of the mites? So you brushed on it pretty much exactly, and that so mites we know are highly susceptible to changes in temperature and humidity. We've tried to rear them in the lab. It hasn't exactly gone very well for a lot of cases, because they are so sensitive. Like, you can't rear them in a incubator that would use to rear bees. The bees will come out, but the mites do not. So they are very sensitive. And it's possible that if bees are more attuned to what's going on inside a cell, and this could be via larval signaling, or it could also be some detection of the mite, when they open these cells, they could create enough of a disturbance. And there's two ways it can affect Varroa. One is it could hinder egg laying. So the foundress usually lays a male egg at the top of the cell because it is before the pupation of the bee, and it's to protect the egg from the movements of the pupa who might destroy the egg. So the male egg is always laid on top. And recapping, we know, happens quite early post-capping. So the bees will start recapping a cell quite early, sometimes before pupation, sometimes after. And it could be that every time they open the cell, it could scare the mite enough that she abandons the attempt to egg lay and goes back and hides. And now the timing is also very important for Varroa as well. They have to lay those eggs at specific times, because if they lay them late, there's a chance that the mites might not mature fast enough to actually escape when the bee emerges. They might be too young, and then they die in the cell. So that's one way it could reduce reproductive success. And we actually have noticed the offspring count is lower kind of for across the board for all offspring in colonies like the Norwegians, the Swedish, and the French populations. So reason two is to how it could affect the reproductive success of Varroa, and that is mating. So the Varroa mate inside the cell. And if the cell is opened and enough of a disturbance is caused, it could actually hinder mating. So it could delay mating or stop mating altogether, in which case you would have mature foundresses that haven't been mated properly and therefore will have a reduced reproductive success in the next generation. And how you would test for that is you would probably do some sort of sperm count in the males from surviving bees, and then take control. I have not done that yet. I don't actually have the equipment at Norby to do it. So if there's one researcher wants to do this and publish on it, please go do it. And it would be really fun to know.
Yeah.
So those are my two theories. As of yet, unproven. I would love to get some more answers on that. But what I'm working on now, specifically because we have such limited resources, and we don't have a lot to work with here. So I've relied on the beekeepers here who are interested in working with me to do these projects. I'm working on more of an applicable approach to harnessing these abilities. and harnessing what we know. So working with beekeepers, applying a breeding program that's run by the beekeepers, and they take my advice based on the data that I get off these populations. I run a selection algorithm and I make suggestions as to which hives might be the best in terms of Varroa survivability, honey production, and docility. Those are the three main ones.
Interesting. So you are in the same boat apparently that I am, and the things that are bothering me is like when I see those. It's been 20 years in the same thing, and I see this over and over, and I don't see much progress in my point of view. Like something that we are moving to a better solution, a better situation right now. I don't have that in my mind. So I want to ask you, because this happens all the time. We see something that we believe is responsible for something. We never 100% sure because, we talk about, repeated in this podcast already many times, the amount of variables are humongous. But we see something new and then we start to select for that. And that never ends very well in my account. Like I would say, we have some of this momentum, but then in the long run, things go back problematic. I always conflicting with myself. Should we keep going with the same way of selection, or there is ways to improve our selection systems to the point that we're going to see results that is tangible for the final beekeeper? I don't know if I explained myself very well.
Yeah, it might need maybe a little bit of context for that. That was a very general.
Let's find some examples. Let's put this example, for example. We found that recapping. We know there is tons of other variables that might be influencing in the final goal, which is the reduction of overall replication, right? So then we start to select for that, and then we put other things that beekeepers also want involvement at. Higher production of honey, higher this, higher that, and then we select that. But in nature, the final, natural selection doesn't have rules. It is what it is. Whoever survived with whatever, quantity of honey or amount of swarms per year, whatever. There is a lot of things that we never able to quantify in nature that might be responsible for the survivalship of that specific colony. And sometimes I think that we might be so bold to think that we are able to do those selections in our favor. I mean, that's the point. In our favor, it's not the favor of the colony, because if you leave them alone, they already proved themselves they survive well. It's how to make the selection that attend our own benefits and keep them with some, advantage also in nature, so they can survive better. I
think I get it. So the nice thing when we're talking about honeybees is that in a lot of cases, it's already happened. So we have beekeepers who've been able to breed resistant stock that are also productive. It's happened in Norway. There's been no published on it, but I know a couple of other beekeepers have figured it out and they're doing it and they're selling their stock and stuff. But it brushes on, how much we're willing to examine the natural systems, learn about natural systems and pull from that and use it. Human beings are effectors. So they always change their environment. And I don't expect that to stop. What we can do is get better at how we're changing the environment, learn more about the environment so we can integrate elements of it and create kind of sustainability for our practices. I think sustainability is going to be a big buzzword in it is already.
Yeah,
but we really need to reevaluate our systems and how to have these ecosystems persist alongside us rather than steamroll them for profit, because that's not sustainable. It will not. We cannot keep doing it. It won't happen. So
reach the point. We do it, and you never reach the point, and there is those big failures along the way that I can see right away. And I think
we're all in this together.
Yeah.
So it's not just the beekeeper per se. It is all the landowners around them.
Yeah.
And how the landscape is changing.
When I was explaining my point, I missed something important to you, which is, yes, we are selected. We have something that worked for us in that, but then people want to sell that stock to other environments. And I see gigantic failure.
Yes. Okay.
That's the problem. That's the problem. I forgot about this missing piece, which is very important one, because
it's a very important one. So
I'm advising people to select locally.
Exactly.
Bring something from far away, different, selected, in a different environment, completely different.
Yeah. And that's one of the main arguments when people, because a lot of people still don't believe the fact that a lot of stock is actually surviving, because they're like, well, we imported them here and then they died, so they're not surviving. It's like, yes, they are. The conditions are different. So I promote basically the same as you. Is like, if you have the capacity to breed locally, do it, because the bees that are adapted to your specific environment are already accounting for challenges that you can't account for, you can't assess. Bees are unique in livestock animals that you cannot control every aspect of their day-to-day lives. You don't know what you feed them. They go out and find their own food, and they'll bring the honey back to you.
Yeah.
So
very important, very topic part, and something that I want to try to do with the breeders. If you can incorporate some sort of metrics that when you sell a stock, you need to sell with the information about the environment that stock was selected. Because then people, different markets, they can look at not only, okay, this is a queen that's, is for mites, but if you bring them more information with that queen, so that was selected in this kind of woods, with this kind of, humidity all over the year, if you have this more, more data, maybe people are going to start to buy those stocks for other reasons. And it's going to start to work in different places because, okay, for my environment, I need to get that breeder from that place that is very likely to my environment. And then I'm going to have higher chances for that selection, whatever selection happened over there, to work on my operation. So that's something.
In addition, the other piece of advice I would give to beekeepers is, once you have this surviving stock, whether you buy it or breed it, you have to keep selecting. This is not, you can talk about fixed traits and dynamic traits, but the thing is, all traits are dynamic. All traits are changing. And the bees, basically selection for the bees is going to happen for the bees unless you act upon it. You apply pressure to the system and bring the traits back to what you want. So, when you have this stock, you need to keep selecting for the best queens. And I strongly encourage, if you have the capacity, to breed your own queens.
So, Melissa, do you see any other traits on those hives, on those colonies, in those populations? We talk about, recapping. There is more traits that you saw or that could be involved also in the interference with Varroa replication?
Yeah, so as I said, there's I suspect quite a number of traits. There was a paper put out recently that I was on looking at the brood element of this Varroa control, and they actually did find that the brood it's possible that the brood could affect Varroa reproduction as well. So something in the volatile oils, the hydrocarbons, something that messes with the timing of egg laying of Varroa. It's possible. There's been a couple of papers published on it. It's a possibility. I do know the Norwegian stock is quite hygienic. It's quite attentive to foreign elements in the hive, all foreign elements. I rarely see chalk brood. The beekeeper himself actually did a little bit of selection with black ants, because ants are one of the main predators of beehives up here in the spring. So how quickly they jumped on ants and drove them off as well. So he did that selection as well. So they're not very tolerant of other bees or foreign elements in the hive. So that probably could play a role. Like I said, I did test for grooming, but the problem with using damaged mites as a proxy is it's not very reliable. So there still could probably be more tests done to see exactly how much grooming and how successful it is. Because the other thing is, mites, they are exceptionally good at not getting caught. The hydrocarbons on their backs kind of replicate the scent of the colony in a few hours. And then they're completely invisible. They hide under the abdominal segments there. They just hide right under there, and the bees cannot get them out once they're there. Grooming is probably still a thing, but it's probably not the main thing. Like I said, it's probably a mix, which makes the selection so hard, which is why I'm focusing on performance to see what we get. So just looking at the bees that can survive and have low mite numbers consistently and giving them a score based on that.
Yeah, it's always a mix of things that people need to understand. That it's not one or two. There is no silver bullet. Let me move forward. I want to ask you something. What does this mean for beekeepers facing Varroa mite problems around the world? Where do you see the beekeeping going regarding Varroa control, and what would be the best approaches, I guess, to tackle this problem? Because we are dealing with this, talk about United States only, almost 40 years now, and things are not getting better.
Yeah. Well, I've got a pretty optimistic view coming from Europe. I've been told that from a North American audience. So I can take a look at the microcosm that I'm coming from here. So this beekeeper, when I started publishing on it, he started to become more well known. But this has started even before I got there, as that other beekeepers started buying his resistant stock, local beekeepers, and now they've created kind of almost a buffer region where there just aren't so many mites in the system, because most of the beekeepers around him that have bees on the land close to this beekeeper don't really have an issue with mites. So I'm hoping that's how it's going to start. It's going to start with these epicenters of people who want to breed resistant bees, who manage to find a successful way to do it in their own areas, and it just kind of radiate out. There's a few people in England that are doing it, and there's probably a lot more beekeepers doing it than I know of at all. I know there's a couple in the States who are trying with and having some relatively decent success. There's also some national breeding programs that are doing pretty well. I haven't read up so much on the Pauline lines or Pauline 2.2, but they seem to be fairly successful. So eventually, we're gonna solve it as human beings. This is what we do. We solve problems. We have to learn from the systems, and we have to improve our techniques. And I think we need to hang on to sustainability, because that's going to be a very important factor. And I think eventually, one day, Varroa isn't going to be a very large problem. One day.
I believe that's true. But the question, I think, to me is how to get there with the minimal suffering from everybody involved.
That's the question.
That's the question.
That's the question. So, I mean, from my experience, my part of the elephant, start small. If you got a massive operation, don't try and change all your stock at one time. Start with a bee yard. Start with a few colonies in your backyard. Run tests, do experiments, read everything, and then make up your own mind about stuff. Don't just believe the first thing that people tell you. Don't believe what I say. Go and read and find out for yourself.
Melissa, there is another topic that apparently I'm the minority here in the United States, and even my peers don't talk too much about that. But doesn't matter how much fact I can bring to the table. Oh, those populations that you are studying, can you give me a little overview about how much pesticides are they exposed to?
Cool question. In terms of what the beekeepers apply, next to nothing. So Norway, I know, has very, very strict regulations on pesticide application in the fields. We're not using neonics out there. There's probably some glyphosate, stuff like that. But the pesticides, I would say, in Norway, very minimal. And they are not allowed to use acaricides on their bees. It's organic acids only for the whole country. Okay. In terms of other European countries, I do know pesticides are applied. I do not know to what extent, on which crops, how they are applied, when they are applied, and what their effects on honeybees are specifically. But I do know that Europe does have very strict regulations. So the neonics are permitted to be used in emergency cases, and I think there's a couple that got reapproved. But yeah, I mean, in terms of how that is affecting the system and how that's affecting Varroa and stuff, there's a lot of literature on what they're capable of. But I would say honeybees are probably going to be one of the last insect species that you're going to see an impact on in terms of pesticides. They are more resilient than other, like solitary bees, for example. They're much more resilient against pesticides than those. So if we see honeybees having a problem based on pesticides, then we're pretty deep into it and we need to stop.
Yeah, so pesticides, they're not too much of an issue. It's very likely much less.
I would say there's probably more applied than we are aware of. Because, I mean, people get a hold of these things, they use them. A lot of people don't really follow instructions. So this is all speculation. I don't have the numbers to present to you.
I have examples, tons of examples, and that's the kind of thing that the reality in the field, it is not the reality of whatever the regulatory people are looking at. Yes. But it's hard. This is a lonely battle of myself, I guess.
Yeah, I mean, I can understand where people are coming from. A lot of people applying these things, they're farmers too. They have quotas to make. They have families to feed. And if something happens that scares them, they might lose their crop. Like you said, that could spell disaster. So I understand the logic in a lot of the decisions made. But we should probably be thinking about making decisions together rather than on an individual basis.
Oh, well, just, I always follow what I don't think we can solve any problem if we don't face the problem. Like
Talk about the problem.
If we ignore a problem or pretend the problem doesn't exist, we're never going to solve a problem. So that's always my point. We're going after the truth. So if pesticides are involved, we need to know. We cannot just...
They are definitely involved. They are definitely involved.
I can't prove it, demonstrate it, but not only that, but there is procedures, there are people, different hands, there is a lot of variables.
Yeah.
We cannot...
And as beekeepers, we do have a vested interest in the health of the ecosystems around us because those are the ecosystems that our bees use.
Yeah.
So we should be teaming up with conservation organizations in terms of protecting the environments around us because those provide the floral resources that our bees need. It's not just cropland. In fact, it's much healthier for the bees if it isn't just cropland that they're harvesting on.
Great. Yeah. So I like it. I like your view. We need to work together, all those organizations, and don't close our eyes for the problem. Otherwise, we can't solve any problem. Melissa, I want to ask you a final question. Where people can find your work? Well, how can they find you?
Right. So I've got profiles on a couple of websites. I am on LinkedIn, but I don't often update that with my scientific research. Where you can find my papers is a site called ResearchGate. And you can probably post a link to that. I can give you my profile link as well if you'd like. And then also Google Scholar. So if you just type in Google Scholar into the Google search bar and then hit the first hit, and then you type in my name, it'll bring up a profile for me. You click on that and it should give you pretty much everything that I've been an author on so far. So you can read everything I've published. And if you encounter a paper that is paywalled, I don't think I have very many, but I think there is a couple. And then paywall happens when the authors themselves can't afford the astronomical publication fees that these journals like to charge. So they lock it behind, so they make the public pay. If you come across an article that you would like to read that is paywalled, do send me an email because I can send it to you for free.
Yeah, and you can even, I think in ResearchGate, you can make it available to everybody there too.
As long as it's not paywalled, there's some legal. I think they got into legal trouble with that as well. But you can request the article from the author, and the author is legally allowed to share the article with anyone who emails them personally. That is allowed.
I will leave a link of all those things we're talking about here in the podcast notes or in the description of the video, so you guys can contact Dr. Melissa by email or whatever social media platform you want to start communication with her to know more about her work. Melissa, I want to thank you very much for your time. Was a great conversation. I learned a lot.
Thank you very much for inviting me. It's fun to talk to a North American audience about
to see what's happening all over the world regarding Varroa. I'm interested much more and more about this. Let the bees take care of Varroa themselves. So I will keep updating the people with. I'm probably gonna publish 1 or 2 videos about your work, then this podcast. So yeah, we're gonna be talking about your work a lot.
Happy to help. Yeah, you can always reach out to me. This is I can talk bees all day.
All right. Do you have any other message to people at home?
Hang in there. It will get better.
Okay.
We got to keep trying.
Very positive. Okay, good. Melissa, thank you very much for your time. And you guys, thank you guys for listening to the podcast and to watch the video. It's always a pleasure to have you here. Let me know if you have any questions and comments. Leave in the comment section below or send me an email at contact@insidethehive.tv. And I'll try my best to answer those comments and questions. And until there, see you guys in the next one. InsideTheHive.tv, the show about bees. See you guys next week. Bye-bye. InsideTheHive.tv podcast is brought to you by our fans on Patreon. On Patreon, you can access all episodes before anybody else and exclusive content, like behind-the-scenes videos, live streams, and more. If you want to learn more about honeybees and help me to make more content about honeybees to everybody, please visit patreon.com/InsideTheHive.tv and join our community.